Hello students and welcome for the lecture of 3D printing application in various industries. As we know that the 3D printing has a rapid extended beyond a prototyping to full scale production due to its ability to reduce the lead time, then minimize the material waste, and it has an ability to generate a complex geometries. Initially, it is adopted in a aerospace and automotive sector for lightweight and customize the complex geometrical components. In the nowadays, the majorly it used for healthcare centers, or you can say healthcare industries like a prosthetic, then bioprinting. We are using such kind of technology in construction works also to making the 3D printing houses and infrastructure, as well as in a food applications and others. So in this video we will discuss what are the different type of applications which we have to gone through, and there are two applications which are currently we are discussing in this today's session. So here are the various applications as shown which need to be discussed: automotive, defense, coin, householding appliances industry, toy industry, then unmanned aerial vehicles, furniture industry, construction industry, and food industry. So today we will cover the automotive industry and defense industry, or you can say defense sector. So the most important why we need to a 3D printing in automotive industry, as the automotive industry has a long milestone globally for innovation in driving progress in engineering, manufacturing, and design. So we are using this 3D printing technology in the automotive industry itself. The benefit related to the 3D printing, which has been used in automotive industry. So in the originally the 3D printing has traced from 1980. The technology has started from 1980s. Based on that, the first 3D printed automotive technology has developed, or you can say implemented, in 1990s by General Motors, Ford, and BMW. They have used SLA, FDM, and SLS technologies to create a polymer based prototypes. Initially, in automotive industry, they are only using for prototype manufacturing. Okay, so before uh, discussing the historical milestone, initially we will discuss what is the basic role of 3D printing in automotive industry. So here on the screen there are five initial segments has been shown. First one is a rapid prototyping and design validation. The faster integration, it is nothing but a quick produce a physical model of design concept, and it enable to for rapid testing and refinement. So whatever the concept which have with the designer, they can rapidly create the prototype model, and they can utilize, or you can say they can take some test whether the material is capable or whether the flow is um, uh, acceptable. So these things they can check with the design, and they by conducting the various tests they can validate whether the concept is up to the mark or not. The next one is a concept visualization. As I say, when you making a prototype, that creates a realistic prototype from foam, fit, and ergonomic evaluation. Next one is a functional testing. In the functional testing, the print functional prototype for early performing test has been conducted. The test like a aerodynamic test and fluid dynamic test has to be conducted so that you can compare this data with the previous available vehicles data so that you can understood that the drag or any concept or you can say any particular parameter you are considering for design or for development that has to be changed. Then reduce the development time as the 3D printing takes very lesser time as compared with the conventional method. So the significant shorten the cycle for design concept to physical part. Second one is a tool fixture and manufacturing aids point of view. So the custom jig and fixture, the printing specialized tool for assembly line and inspect and hold the parts during the manufacturing process. In the tooling, fixturing and manufacturing, there are two types of tooling are there, softer and harder tooling. And again in that there are again two types, that is direct tooling and indirect tooling. So in the same cases we can use 3D printed tools or 3D printed fixtures for manufacturing purpose also. Then we can make on demand critical complex models and patterns for casting, that is on demand tooling. Then ergonomic improvements as a design and printing custom the tool tailored to worker which needs to enhance the efficiency and safety of the design. Then cost and time saving, it can be save up to 50 to 70% of the total cost or you can say total time with respect to manufacture design concept to manufacturing. Third one is a end use part production, that is low to high volume. As we know that the 3D printing is generally used for batch or low production production number of quantities. Now customization and personalization that produce the bespoke interior components, trim pieces or accessories for individual customer preferences, that can be we can provide it or we can manufacture with the custom uh, or personalized application point of view, as the customer has their own uh, optimize or you can say own needs that they can provide to the designer, and based on that the customized objects can be manufactured. We will see these kind of all aspects in our case studies. The next one is a higher performance component. Next one is the lightweighting. As the design and printing is more complex and the optimized parts like engine components, structural elements or brackets with superior and strength to weight ratio is lesser as compared with the traditional manufactured components. So the weight is getting lighter. An example we can use um, EVs nowadays. So the most of the parts are manufactured with the help of 3D printing. High performance component manufacture intricate heat resistance, then high strength part for racing vehicles and performance model. In high performance components like intake manifold, exhaust parts, suspension components are now manufactured with the help of 3D printing also. There are metal 3D printers, from that they can manufacture such kind of complex and high strengthened parts. Then obsolescence and the spare parts. Nowadays, the production of the customized parts has been quite difficult, or as compared to the production point of view, these parts are very less, so that the production of these parts are making too much costlier for the industry. So that we can use, with the help of 3D printing, we can directly prepare or can manufacture these spare parts, so that it can reduce the inventory cost also. Next one, part consolidation. In the consolidation, a design single integrated parts that replace the complex assemblies, reducing the part counts, weight, and assembly time. So that the consolidated part has been developed with the help of 3D printing. Then supply chain and logistic enhancement. Uh, Decentralized manufacturing, as we can manufacture these items, or you can say spare parts, whenever we need it, and which is closer to the production which is happen, or we can convert, that is closer to the dealers or repairing shop, so that the supply chain and logistic enhancement will be improved with the help of decentralized manufacturing process. Reduced inventory. As we know that the mostly norm in automotive industry, the company has manufactured the multiple components or cars or basic material, and they can stack in inventory warehouses, these inventory in warehouses. So whenever necessary, they will call and utilize it. But by keeping this inventory in a warehouses, they can occupy the space in between the warehouses, and again there is a problem that inventory cost, inventory is, stationary cost is included in this total cost, so that the cost of total the part is getting increased. So reduce the inventory cost, we can minimizes the warehouse cost by printing these parts only when required, and it is located nearby the repair shop, or you can say nearby the manufacturer shop, so that we can uh, reduce the inventory time also. Supply chain resilience, it offer an alternative to traditional supply chain, mitigating the risk from dispersion. So based on this, you can optimize the supply chain also with the help of this uh, user make and deliver 3D printed parts. Then digital inventory, maintaining the digital design files rather than the physical stock for many components. As we know that the 3D printing is needed the digital, that is 3D uh, file as in the STL format. We can utilize, we can store these files in a normally in digital manner, so that the physical data has to be does not required to be stored or stacked in the industry. Next one, innovation and future application. So in a generative design, as the AI to create a highly optimized and often organic shaped parts, especially for additive manufacturing, which maximize the performance and minimize the material usage. So based on this, we can, as the process is we simplifying with the help of supply chain, then required whenever we can manufacture when the part is to be required. So in that way we can use with the generative design also, and more or less the number of part which is specified are the customized, so the quantity may be required or may not be, so it is totally depend upon the customer's requirement. Then sustainable materials. We can use recycled plastic for manufacturing the 3D printed parts. Then now the bio-based resins and sustainable metal powders are used to manufacture these 3D printed parts as a raw material. So it will not be harmful for the environment. Full vehicle structure. Uh, Exploration and limited production of entire vehicle bodies or chassis is primarily made with the help of 3D printing, because this is the most important part, which is the structure of a vehicle, which can be manufactured in a single set as a single body. As I say, the part consolidation, it is nothing but you can reduce the sub assemblies and convert into the single assembly. So similarly, the full vehicle structure we can manufacture with the help of this 3D printing technology in a single set, rather than manufacturing the different assemblies and then assemble it. Advanced functionality. The printing embedded electronic sensors and even the energy storage system within the vehicle component, so that we can track the total uh, process of the of the vehicle. So how it works, how the process is going on, then we can get a real time data. Nowadays we are going with the unhumanized vehicle, so the continuous data is requirement, and it has to be uploaded to um, the server, so that machines are getting communicated with each other, and then only they can go for further process. So we can have a different case studies to understand the application of 3D printing in automotive industry. As we know, there are various companies like Ferrari, BMW, Ford, local motors, Audi, Porsche, Bugatti, Volkswagen, Mercedes. They are using 3D printed parts in their vehicles. So started with the first case study, that is Porsche has used 3D printed custom seats. Now Porsche has recently in 2020 they have manufactured these 3D printed custom seats, because they are introducing these custom seats for sports car that leveraging 3D printed and lactic design. New seats features the polyethylene 3D printed central seat and the backrest cushioning section, which can be customized by three firmness level, that is hard level, medium level and soft level. With its personalization, the seat, the German automaker is making cue for motorsport sector, where the customized driven specific seated fitted in the vehicles. In the mid of 2021, it is fitted in the vehicle. In the case study number 2, the 3D printed automotive brackets. The brackets, we know that it is a small and rather the small parts which are difficult to optimize in a past, when the engineers were constrained by traditional manufacturing method. Today, engineers can be design optimized bracket and bring this design to the life with the help of 3D printing. The Rolls-Royce has recently showcased the capabilities of 3D printing for bracket. As the in case number case study number 2, the bracket has shown, which is manufactured by Rolls-Royce. The logo has been shown over here. So the company showed off the large batch of DAM optimized 3D printed automotive metal parts, many of them is which is shown in this figure. The cost saving and faster production and design optimization are typically the main reason to use additive manufacturing for manufacturing to produce the brackets. In the Rolls-Royce example, the team has able to incorporate some really cool features into the parts, including 3D printed brand name and QR code, which is shown in figure. Along with the numbers, it can identify the specific and unique part data. Okay, so with the help of 3D printing, they have done this development. Next one, in the third case, the Ford 3D print part for high performance Mustang Shelby GT500. The Ford company is one of the earliest adopted 3D printing, having purchased the third 3D printer ever made from last 30 years. The Ford, which opened it with the additive manufacturing center in 2020, they have integrated 3D parts developed cycle with their own manufacturing applications. In 2020, the Shelby GT500 is the one of the example where the parts has been manufactured. The virtual design test has been the key part of design process for the high performance vehicle. While the virtual testing, more than 500 cooling and aerodynamic 3D designs are analyzed to enable the team to reach the downforce, braking and cooling target. Once the most promising design were identified, then Ford engineers team using the 3D printing, it created the prototype. For instance, the team 3D printed the 10 test designs and the check they have got the quality or the design they have developed or optimized component is very useful as compared with the traditional manufactured component. This carbon digital light synthesis, that we can say DLS, 3D printed technology and the epoxy 82 material which passes the performance standards which is required or set by the Ford company. Fourth case study, Volkswagen use the 3D printed manufacturing tools. While the prototyping remained the primary application of 3D printing in the automotive industry, in 2014, the Portugal manufacturer Volkswagen is used this 3D printing application for tooling purpose. Using this technology, the number of advantage they have identified, they procuring its tool internally reduced by 90% lead time when they have started the manufacturing of their tooling with the help of 3D printing. Uh, they have given an example like the lift budget, which is shown as in a figure, repeatedly takes 35 days to develop this component with the help of traditional manufacturing, and it takes about 4,400 euros um, for similar component. With the help of 3D printing, they have manufactured same tool within a week, and the cost of this within a day, and the cost of within a 4 day, and the cost of this tool is only 10 euros. So nearly they have saved about 3025 euros in 2017 only for manufacturing these tools with the help of 3D printing. Next case study, that is 3D printed hypercar. The 3D printed hypercar is nothing but it's a concept in 2010 early. The excitement of the manufacturer or automotive industry is to create something innovative, and for that the these hypercars are developed, or the total body of this hypercar is developed with the help of 3D printing technology. The local motor is used to manufacture these 3D printed chassis as shown in figure. They have manufactured the total chassis in mid of 2010 with the help of this 3D printing technology, which is hyper, or you can say concept car, which is manufactured with the help of 3D printed in 2010 by Local Motors and EDAG company, which is exhibited in a SEMA event. Similarly, they are using 3D printing to manufacture the different hypercars, which is published, which is manufactured with the help of this 3D printing. In second figure, it is shown that Yo-Yo car is the first mass 3D printed car, electrical car, which is used in Italy. The total manufacture, the car has been manufactured with the help of 3D printing technology. More about 2000 number of components has to be manufactured to assemble this car, and the weight it can carry is up to 4,450 kgs. The design is totally lightweight. Next one, the improvement engine performance with the help of 3D printed interactive design. The forged motor has makes the components or parts for their cars with the help of 3D printed technology. When the Toyota Yaris GR was released in engineer at a forced notice the new opportunities to improve the inlet duct design, which moving the airbox opening and increases the overall size of the part. That would reduce the fluctuations in intake air temperature, that is IAT, which make it harder and anticipate the engine performance, which reduces the average temperature overall. So that with the help of SolidWorks they have created the virtual design, with the help of 3D printing they have manufactured, and they cut down the temperature from 40 to 45 degree to 35 to 36 degree. So it can increase the overall performance of the vehicle. The case study number 7, 3D printed spare engine parts. The Parazzani motorcycle in 2012, they have challenged themselves and fabricated the 3D printed intake manifold for their own bike with the help of FDM 3D printed technology. They have used the AutoCAD Fusion software to making the CAD model of this. The scan of four-stroke engine, which with its frame and carburetor, helped him to correctly resize the manifold and then to position it in optimal condition with the help of reverse engineering for this design. With the help of this CAD software, they have properly identified the CAD model, and they have created the t- appropriate uh, pressure which is needed inside the manifold, and it can reduce the turbulence inside the manifold. So based on this design and manufacturing, they have reduced the temperature from 40 degree to 32 degree, and it have increased the capacity by 10%. Now next application, that is defense application. In the defense application, again the few points we need is important with why the 3D printed components or 3D printing is important for defense application. In military application, the innovation is needed continuously. Continuous development is needed. Then there are various aerospace, or you can say ships, which requires lesser in weight so that they can easily travels more distance with minimum time. So for that, the countries like US, India, Israel, China, NATO, they have make an alliance, and they have used 3D printed drones, novel structures, and aerospace parts for defense applications. So there are basic different roles, 8 main roles in a 3D printing for defense. First one is rapid prototyping and system development, which can accelerate the R&D cycle, which creates a, which can create the new weapons and new components and new vehicles with minimum time. The concept visualization, it can shows the 3D printed parts, can shows the actual testing design, which is integration is needed for aircraft, vehicle, drones, and mun- then first engineering change, sorry. The implementation of these design manifolds or modifications quickly without too large tooling, we can directly implement with the conceptual design. Then it can reduce the, as we can manufacture it with the minimum time. It takes minimum time to reduce to the market. Then customization and mission specific solution. As a tailor component which can create a unique design for specific mission, environment, and platform. The ergonomic equipment design customize the soldier gear, weapon interface, and the cockpit controls for individual needs. Specialized payloads that can be developed to unique mounts and housing for sensor, weapons, and communication system. Then repair and sustainability, sustainment and field readiness. The demand spare parts is required at minimum time. So the with the remote base, we can create 3D printed part and provide the supply to as per the demand. Expedited repairs. The quick manufacturing components need to immediately repaired, minimize the downtime for the components like vehicles, aircraft, and vessels. Then obsolescence management, produce the part for aging platform where the original tooling may be lost or outdated, so we can as per requirement we can manufacture that. Then reduce the logistic footprints, and the print parts are locally manufactured, so it can be reduce the transportation. Fourth one is reduce weight reduction and performance enhancement. In overall, with the 4 points, we can say the design print the complex optimized structure that's specifically lighter than the traditional manufactured parts, and improved aerodynamics and hydrodynamics created highly optimized shape of aircraft, missile, and no, naval vessels. Then enhance the structural integrity by achieving the superior strength to weight ratio, increase the optimal range, payload capacity, and other things which can be optimized. Then thermal management, which can be the design has in such a manner that the internal cooling channel for the engines, electronics components, and weapons has to be designed, or we can design. Then supply chain and agility resilience. So the inability of production capabilities closer to the point where it needed, so that it can reduce the decentralized it is concept of decentralized manufacturing, which reduces the lead time, and the inventory or masterpiece we can secure in a digital manner, so that the loss of masterpiece uh, should not be the consent. Then increase the optional flexibility by responding the rapid to change in mission requirement and battlefield condition. It can change the design of component also, so that we can manufacture the required uh, weapons, vehicles, or the required machines. Then cost reduction as the lower tooling cost, uh, which increase actually the tooling cost is generally increases the total cost of a component in a traditional manner, as we can manufacture with the help of 3D printing whenever it required. So tooling cost is very much lesser. Then intricate the design, which create the geometries impossible with the conventional methods. We can design and develop and manufacturing with the help of 3D printers. Then multiple material printing, yes, with the help of in the new era, we with the help of combine different material, a single print of component with the varied functional properties can be manufactured. The next one, advanced material and complex geometry. In the advanced material and complex geometry, we can manufacture the complex geometries with the help of aluminum and titanium materials, like advanced alloys, like that is a high performance alloys like titanium, uh, inconel, so that ceramic, composites, polymers, so it can withstand with the extreme conditions. Um then intricate intricate the design, so that the critical components is unable to manufacture with the help of conventional system, we can manufacture with the help of 3D printed system. Then also we can combine different material and manufacture the multi properties multi property component with the help of 3D printer. Then training and simulation, nowadays in US and UK they have trained their forces with the help of virtual VR and AR system, as well as they can manufacture the 3D printed realistic models of an enemy, so that they can go with the close combat and the other processes, or you can say other trainings has to be other trainings can be conducted with the help of these 3D printed components. We will see a case study on that also. Now the few case studies. First case study, the first 3D printed firearm part, that is M16 rifle lower receiver. In 2000, in this is the first time the 3D printing is used in a defense application. In 2013, the American gunsmith has manufactured the 3D printed this part, which is AR-60 M16 rifle lower receiver, which is having a .12 caliber pistol, sorry, which is used for with the help of solid metal. The bullets can be used uh, as as per the conventional machine. It works with a similar performance. The right side, the Labator is the first 3D printed hand machine single shot gun, which is manufactured in 2013, May 6th May in 2013. It is designed by US government for utilization of 3D printing in this ARM application. Second case study, the 3D printed drones for military usage. In 1984, the first time the 3D printed drone has been used by Israel. In 1989, the 3D printed drone has manufactured with the help of FDM technology. Then the quality is improved by SLS technology with the help of SLS in 1990s. Then in 2000 they are using metal laser sintering process. Now in 2000, after the 2000, they are using electronic beam melting system with the help of additives. Now the multi-jet fusion technology in 2024 is introduced, and they are using with the help of this technology. They have created the 3D printed drones for military applications. Now next one, the 3D printed spare parts for defense. The 3D printed in COVID, there is very difficult to supply the material, or you can say 3D the armed forces or spare parts for army, navy, and air force. So in that case, they in COVID 2019, the French military has created the largest 3D printed form in Europe. They have created the different type of components which is spare parts which is required during this COVID situation. The 3D printer is used is a 200 Ultimaker 3D printer. They have produced the parts like a 3D printed cold water filter, and navy. It is uh, too much necessary, and with the help of sea water the filters are getting corroded, and they need to replace with minimum a particular time of interval. But when they have manufactured with the help of 3D printed, uh, the printers are works, and the cost of manufacturing also reduced by 98%. So it's a big achievement has been done with the 3D printed components in a naval application. Next one, the tools and equipments enhancement. In another case, the Royal Netherlands Air Force has manufactured the customized turbine bridge, which is as shown in left side, with the help of 3D printing technology. They have used CF10 and Eagers Iglider I-150PF filament to manufacture or to create this 3D printed part. The total, when they have manufactured with the help of a steel, or you can say with the help of conventional manufacturing method, they have used completely 12 weeks lead time to manufacture this component with around cost of 1100 euros. But with the help of 3D printed, they have manufactured this component in 13 hours with cost of 24 euros only. So the performance is up to the mark with the original manufactured component. Another they can use for equipment purpose, that is radio GPS bracket fixing, communication vehicle fixer, radio communication to the vehicle like motorcycle and quad during the mission. With the help of 3D printed, they have manufactured this whole system. They approximately reduce the cost up to by 80%. Next application, that is very important application, medical and humanitarian support during the war. As we know that in the war, the with the help as the explosion and all things are happened, due to that various soldiers and the uh, civilians, they can lost their hands, foots, even though jaws. So with the help of 3D printed technology, we can support these issues with the help of 3D printed parts. Uh, in figure, you can see the prosthetic limbs and arms for soldier has been manufactured with the help of 3D printed part by US Navy with the help of various materials. In one more case, there is in 2015 in Nepal earthquake. There are some refugees are tracked in Kathmandu, where the clamps and cords and wire pipes has been manufactured with the help of this 3D printing technology, that is FDMM technology, and they have saved up to 100 plus people in that area. The Enable voluntary network distributes about 8,000 3D printed prosthetic hands to children in 100 countries, 100 plus countries, using FDM technology with the PLA filament. Now they are using SLS also. Even though NASA has utilized these 3D printed medical devices for their space station during the March mission. Next case study, the Indian Army is constructed modular 3D printed bunker for frontline soldier in Ladakh. As we know that the Ladakh having a temperature lesser than the minus 20 degree. So in this area, it is very difficult to construct construct an houses which can provide the particular temperature to the Indian Army, as we know that it's in a high altitude region where the material, what you can say, where transportation of material is also very difficult task, and the logistic of components or the logistic of any material is the main constraint along the line of action. So in that region, they are using automated constructed 3D printing with the specialized the quick cure concrete. These bunkers are printed on site in just 48 hours, offering the superior blast and bullet resistant strength traditional compared to the traditional structure. This innovation significantly reduced the resilience and complex supply chain and labor intensive construction, enabling the rapid customized fabrication for front faction of forward position. The project not only enhanced the immediate soldier safety the operational readiness, but that it can provide the Indian strategy commitment to leverage and cutting edge technology for defense infrastructure with the potential application for future military and disaster management. Next application, where the US Navy, they have a huge class submarine that name is Virginia. The class submarine having a that US Navy has manufactured the submarine propeller blade with the help of laser powder bed fusion technology, and with the help of CNC machining also they have manufactured this submarines propeller blades. Even though they are using the material like titanium, that is an Inconel 718, which achieves the reduction in 80% of weight of that blade, and which directly contribute to increase the speed of this submarine. Now they can utilize this newly manufactured the propeller blades and shaft, so to increase their uh, improvement in a cooker operation, the 50% of faster production as compared to the casting significant, which is accelerated, so that their manufacturing or repairment has been done with the help of 3D printed components only. Next one, the Eurofighter Typhoon fuel tank support has been manufactured with the help of 3D printing technology. In 2019, the BAE system leveraged a laser powered bed fusion to consolidate a complex fuel tank support structure for the Eurofighter Typhoon. Traditionally, this component requires 14 separated parts manufactured and assembled through conventional method, but with the help of 3D printing, it is enabled to redesign and production of the entire structure in a single integrated with the help of using titanium material. This consolidation dramatically reduced the assembly time by 90% and streamlining the production and eliminating the potential point of failure. The lighter weight of this component contribute 5% improvement in fuel efficiency. This project showcased the power of 3D printing in the defense application. Now last, second last, that is India has used 3D printed components that inlet duct in Tejas. As we know, though, our defense research development organization, that is DRDO, which applied the direct metal laser sintering to produce the air intake duct for Tejas light combat aircraft in 2020. The utilization of Unconel 718, a high temperature nickel superalloy for DMSL process, which enables the creation of the duct with the high complex internal geometries that are impossible to achieve with the traditional manufacturing. It leads with a significant of 8% improvement in aerodynamic efficiency due to the smoother airflow and reduced in turbulence. Additionally, the 50% of reduction in production time accelerate the aircraft development and production schedule. This case study demonstrates the utilization of 3D printing has been accepted by India also in our defense system. It also you can utilize for fighter jets also. Next one, the NATO aligned the training with the dummies. As in 2022, the NATO adopted the multi-material polyjet technology to produce the advanced training dummies for combat medic training. Using the silicon and rubber like photopolymers, polyjet enables to create the dummies of realistic wound, then simulation, and including the feature like a blood vessel, tissue layers, and layering tissues hardness. This provides the highly realistic trauma training that closely gives the feel of combat training. The 3D printed dummies are 60% cheaper as compared with the traditional manufactured these dummies. So the training cost is get totally reduced with in this case. So in this lecture we are concluding that we can use 3D printed technology in various applications to increase the quality as well as to reduce the weight, to reduce the overall time of manufacturing. We can enable the decentralized manufacturing system. We can reduce the lead time. We can improve the performance of and various kind of machines. For example, in automotive we have improved the performance of vehicle. In defense we have improved the performance of arms, aircrafts, ship. So with the help of this 3D printing we can develop and improve the way performance of the components as per the application. So in next lecture we will discuss the various remaining application. Thank you for joining this lecture. Thank you so much.